a little bit. I changed the points up. I changed the translation a little bit. I kept some of the other rules. Oh, and I meant to rewrite this, but I kept it scale factor 3. I guess that's okay. All right. So let's go ahead and get started. The first thing we have is a translation with components -4 and 5. Translation just means shift. And then this right here is your horizontal shift. So how much you're moving to the left and to the right. And this is your vertical shift, how much you're going to move up and down. So each, if the triangle, and this is obviously not exactly what the graph looks like, what we're going to do is we're going to shift it to the left 4 spaces, ... and then shift it up, somewhere up here. Not a good picture, but not important. The most important thing is we understand how to take the points that form the corners of the triangle and move those points so that we can move the whole triangle. If we're shifting to the left and to the right, if we're shifting horizontally, that's an X thing. So if we're shifting X to the left, we have 2 minus 4. And if we are shifting 5, or if we're shifting vertically, we're shifting up 5 spaces, we're going to take 5 and add 5. Right. So 2 minus 4 is -2, 5 plus 5 is 10. So our final values here are just -2 for that shift to the left 4 spaces, and 10 for that shift up 5 spaces. Same thing here, we're going to shift to the left, so 0 becomes -4, and we're going to add 5. So -8 moves up to -3, and 6 and -7, shifting to the left, so we're subtracting 2, shifting up, so we're adding 5, and so that's -2. A reflection across the x-axis. So this is one that requires a rule. A reflection across the x-axis is going to flip, if this is our x-axis, flips the object across. So it doesn't change the x value, but it switches the sign of the y value. So you may remember our old rule, xy turns into x comma -y. So let's just apply that rule to these 3 points. X stays x, so it stays 2. And then y becomes -y, so this is -5. Remember, each time we're going back and using these points. We don't use the points in the row previously. It's like 6 separate questions. So question 1 is done. To do question 2, we go back and use these points. The x doesn't change, so it's still 0. But we flip the sign of the y, so it used to be negative, so now it's positive. And then C, 6 doesn't change. And the y value used to be negative, so we changed that, it's positive. Let's do our rotation of 90 degrees counterclockwise. So every time we do a 90-degree rotation or 270-degree rotation, we always remember that x and y switch places. The other thing that happens is you change the sign on one of them. A good way to remember that is counterclockwise means kind of to the left. So we're going to change the sign of the one to the left, right? This is the left number. So 90 degrees to the left, change the one on the left. That's a nice little trick for us to remember which we switch. So let's apply that rule to each point. Remember, we're going back to our original points. So they're going to switch positions, 5, 2, and we make the one on the left opposite, so -5, 2. They're going to switch positions, so 0 is now here. And then when we move -8 over and we switch it because it's on the left, it's going to end up being positive. So +8. And same thing here. X and Y switch places, so 6 is over here now. But when this Y value moves over, we also change it. So now it's a positive amount. Dilation with scale factor 3, that's easy. You just take x comma y, and then you multiply by 3, you multiply by 3, and that will create a dilation with a scale factor of 3. So instead of 2, 5, we are going to have 6, 15. Instead of 0, negative 8, we're going to have 0, and then times 3 is negative 24. And instead of 6, 7, we're going to have 18, negative 21. Reflection across the line, y equals x. Hey, so if y equals x, that's the same as saying x equals y. And that's a good way to remember that the rule just means x and y trade with each other. X equals the y, y equals the x. They switch positions. So let's just switch them up. Instead of 2, 5, we got 5, 2. Instead of 0, negative 8, we got negative 8, 0. And instead of 6, negative 7, we have negative 7, 6. Rotation of 180 degrees. That's the last one. I'm not going to make it too fancy. Rotation 180. All you do is make them the opposite sign. So negative x, negative y. So instead of 2, 5, negative 2, negative 5. Instead of 0, negative 8, it would be negative 0, which is still 0. But negative, negative 8 is positive 8, so we switch the sign. Same thing here. 6 becomes negative 6, but negative 7 switches also, so it switches to positive 7. That's number 3. It's all those geometry rules we learned back in December right before Christmas. You can always remember, if you forget the rules, but you understand the shape, you can draw out kind of the shape in action and try to look for a pattern, and that pattern might remind you what the rules are. But it's also good just to know the rules. All right, that's number 3. If you need help for number 4, click on the next video. Bye.